Hello and welcome to Maths with Kirin. We are up to lesson 4 in our level 1 algebra series, and today we are going to be looking at adding and subtracting algebraic fractions and simplifying algebraic fractions. Now I know that I did go through simplifying algebraic fractions in the very first lesson of this series. So the fractions that we're looking at today are a little bit more complex in that they require factorising in order to simplify, but that same sort of principle of looking for common factors still applies. So to get through the stuff that we're going to be looking at today, we are going to be drawing on skills that we have covered in the last 3 lessons. So we will be looking at simplifying from that first lesson. So not just the sort of concept of fractions, but also adding and subtracting like terms. And we're also going to be using some expanding and definitely looking at some of the factorising skills that we covered in the last lesson. So that will sort of take us through today. Like usual, I've got some example questions to go through for both of those skills with you, and then I've got a few questions from the last 2 years worth of assessment papers. So I'll go through those and we can talk about how those questions are sort of marked and what you need to do to get different grades for those questions. So we will get straight into it. So adding and subtracting algebraic fractions, the process is the same as if you are adding and subtracting fractions with just numbers. We need to find that common denominator. And once we've got that, then we can add the numerator or subtract the numerators, depending on what the question is asking us to do. Okay, so we might need to multiply both fractions in order to get a common denominator, and then we simplify as we go. When you think that you're at the end, just check, make sure that you can't simplify any further. Sometimes we can still simplify even though we think that we might be finished. So a couple of examples on this page to go through. This first one, we've got 3x over 4 and we are subtracting x plus 2 all over 3. So to get our common denominator, 4 and 3, our lowest common denominator is going to be 12. Okay, I can't use anything smaller than that. So in order to get this fraction with a denominator of 12, I need to multiply both the numerator, the top part, and the denominator of the fraction by 3. So we're going to multiply this 3x up here by 3. So 3 times 3x. And I'm going to create this all over 12 because I know that's my common denominator. So I got 12 by multiplying 4 by 3. This second fraction here, to get our common denominator of 12, we need to multiply this by 3. No, we don't. We need to multiply it by 4. So that means that we need to do the same thing to the top part of the fraction. So we are going to subtract 4 times x plus 2. Okay, and I've already got the 12 down the bottom, so I don't need to do anything more with that. So from here, we're just going to focus on that numerator, so the top line to start with. We're going to expand it out and then we'll simplify. So 3 times 3x is 9x. And then we've got minus 4 times x will give us minus 4x. And then minus 4 times 2, making sure that we're bringing that minus 4 all the way in, will give us negative 8. Our denominator is still the same. We haven't changed anything about the fraction. We've just expanded out those brackets on the numerator there. And now we simplify. So 9x minus 4x is 5x. Minus 8 over 12. 5x, 8 and 12. There are no more common factors. So we can't simplify anymore. So our final answer is just 5x minus 8 all over 12. So we just finished that first question. We've got 5x minus 8 all over 12. For question 2, this time we're adding 2 fractions, but we still want to do the same thing. So we want our lowest common denominator. We've got a 6 and a 9. Our lowest common denominator would be 18 because I can get 6 into 18 by multiplying by 3, and I can get 9 to 18 by multiplying by 2. So that's the best. Well, that would be my suggestion on the best way to go about this. If you did multiply this fraction, say, by 9, and you multiplied this fraction by 6 over 6, then you would end up with a denominator of 54, and that would be fine. It just means that you'll need to simplify as your final step. So we'll go through with 18 first, and then I can sort of show you what it would look like if you didn't use your lowest common denominator. It's not the end of the world, it just means a little bit extra work at the end. So let's do 18. Also, other, I guess, bonus or advantage of using 18 as our lowest common denominator is that you're dealing with smaller numbers, and when you're not allowed calculators, sometimes people get nervous when you start getting bigger and bigger numbers. So using our lowest common denominator will also give us smaller numbers. So we're going to multiply this by 3. So we've got 3 times our top line, and then 6 times 3 is where this 18 comes from. This one here, we're going to multiply by 2, because remember we're trying to get 9 into 18, so multiplying by 2. We're adding our fractions, so we have a plus in the middle, plus 2 lots of x plus 4, and our 18 we've already covered because we're multiplying that 9 by 2. So now we expand. 3 by 5 is 15x, and then 3 times negative 2 is negative 6, plus 2 times x, plus 2 times positive 4 gives us positive 8, still over 18, and now we simplify. So 15x plus 2x gives us 17x, negative 6 plus 8 gives us positive 2, and that's over 18. Okay, so I'll just get a blank piece of paper. If you didn't spot, for example, that you had that common factor of 18, then if we multiply this by 9, so we get 9 times 5x minus 2 all over 54, so we're multiplying 6 by 9. And on this side, we would multiply through by 6, and then 6 times 9 is 54. Okay, so if we expand this out, we get 45x minus 18 plus 6x plus 24 all over 54. And then simplifying our top line, 45x plus 6x is 51x. Negative 18 plus 24 is positive 6 all over 54. So here, 51x, 6, and 54 all have a common factor of 3. So if we divide these terms all individually through by 3, 51x divided by 3 is 17x, 6 divided by 3 is 2, and then 54 divided by 3 is 18. So you still get the same answer, 17x plus 2 over 18, but you needed to spot at this step here that you can divide through by 3. Okay, so using our lowest common denominator will reduce the likelihood that you will have to simplify at the end, and also B, mean that you have smaller numbers to deal with. Okay, but it is useful to just get in the habit when you get that final answer, just do a double check. Can I simplify any further, or is it as simple as it gets? Okay. Okay. This is the last example that I'll go through with adding and subtracting fractions. Hopefully you can read that. We've got 3x over x plus 4 minus 5x over x minus 6. So we're going to go through that same process. In this case, we don't have numbers as our denominators. So in order to get a common denominator, we're going to multiply x plus 4 by x minus 6. So that means, but when I multiply this by x minus 6, I have to do the same thing to the top line. So we get 3x times x minus 6, and our common denominator is going to be x plus 4 over x minus 6. This fraction, we're multiplying by x plus 4, top and bottom. So we've got minus 5x times x plus 4, and we've got our denominator at the bottom already. So from here, we're going to expand and simplify the top line. I'm going to leave the bottom line factorized, and that's because if, when we get to the end, we're looking for common factors, we can only find them if we have our quadratic factorized. Okay, so I would resist the temptation to expand the denominator. Let's just do the numerator, simplify it, and then see what we have. So we get 3x times x, which is 3x squared, minus 3x times negative 6, which is negative 18x. Bringing our minus through when we multiply, so minus 5x times x is minus 5x squared, and then minus 5x times 4 is minus 20x, x, and that is still over our common denominator of x plus 4 times x minus 6. And simplifying, we've got 3x squared minus 5x squared, so that would give us negative 2x squared. And then negative 18x minus 20x is going to give us negative 38x, all over x plus 4 and x minus 6. We can factorize that top line. We've got a common factor of 2x. So if we take either negative 2x, I'm just going to take 2x. Actually, let's take negative 2x out in front of our brackets. We just need to multiply that by x to get negative 2x squared, and then we multiply it by oh my goodness, I'm having to think. 38 divided by 2, 30 divided by 2 is 15, and another 4, 19. Ooh. All over x plus 4 and x minus 6. Okay, so you'll see we've got our numerator and our denominator both factorized, and there are no common factors, so we can't simplify anymore. That's as good as we can get. You would get full marks if you got to this step because there's no simplification. So that's adding and subtracting fractions. A few examples there. We're going to have a look now at simplifying rational expressions, which is a fancy way of saying fractions. So as I said earlier, these fractions require factorising. Once we factorise the numerator and or denominator, then we can look for common factors to cancel. Okay, so this first question, 3x squared minus 12 over x minus 2. So if we take our numerator, we want to look for that common factor first. Remember, when we're factorising, that's always the first thing to look for. In this case, we have a common factor of 3. So if we take that out front, we end up with x squared minus 4. And we've still got x minus 2 underneath. Now, x squared minus 4 might look a little bit familiar. It was one of those special cases. It's that difference of two squares. So we can factorise this into two brackets. Our 3 stays out in front. And we want two numbers that multiply to give us negative 4 and add to give us 0 because we've got no x's. So we've got minus 2 and x plus 2. Multiply to give you negative 4, add to give you 0, and that's all over x minus 2. And so from here, you'll see we've got x minus 2 as a factor at the top and x minus 2 as a factor at the bottom. So they cancel, and we are just left with 3 times x plus 2, and we don't even have a fraction anymore. You don't need to expand that out. That's fine as it is, unless the question specifically asks you to. So just going back, I've got a question about the last adding and subtracting one that we did. So why didn't you factorize the denominator? The denominator is factorized. We didn't expand it because when we're looking for common factors, we need our expression to be factorized. So if we leave it in brackets, then when we did this step here, if, for example, this ended up being x minus 6, then I would know I could cancel this with this x minus 6 at the bottom, and we would have a simplified fraction. Okay? So leaving it factorized means that you can look for those common factors to simplify. If you expand it out, they're not obvious anymore in order to do that. So hopefully that answers your question. As we go through the next couple of examples, you might get a better feeling for how and why that kind of works. Okay. So our second question here looks a little bit nasty. We're just going to take it one step at a time. So we're going to start by looking for that common factor. So on the numerator, we've got a common factor of 4x. So that comes out in front, and then inside we have 2x minus 3. Okay, on the bottom we've got a common factor of 2. So we can take that out, which will give us 2x squared minus x minus 3 at the bottom. So now we want to look to factorize this 2x squared minus x minus 3. So the numerator stays the same. We leave our 2 out in front. And this is one of those ones where we factorize into two brackets. It's a quadratic and it's got three terms. We know we need a 2x squared, so that means that we need a 2x in one bracket and an x in the other. We know that we need -3, so we know that these two numbers have to be 3 and 1. We just need to figure out which way around to do them. We want to get a -x, so -1, so the difference in the two numbers would need to be 1, remembering that one of them is going to be doubled. So if, for example, we had a 1 here, 2x times 1 would give us 2x, and then 3x would go here. So if we did that, we want to get -x. So we could have 1 and 3. That would give us 2x. That would give us 3x. We need to get -x, so we want -3x plus 2x. Okay, so it goes that way around. You can use this as a bit of a clue. If we're looking for common factors, then it's possible that one of these two brackets will be 2x minus 3. My lights have just gone really bright. So that might be a good place to start if you're really not sure. See if you can get a 2x minus 3 and that x plus 1 will work. So now that we've got everything factorized, we can look for common factors. So the first really obvious one is we've got this 2x minus 3 on the top and the bottom of our fraction, so they cancel. The other thing you might notice is you've got this 4x and this 2. They both have a common factor of 2, which means this 2 disappears, and this actually becomes a 2x. So what we're left with is 2x at the top of our fraction, and at the bottom we still have that x plus 1. Okay, and that's as simple as we can get. Can't do any more factorizing, and there are certainly no more common factors that we can cancel. Okay, one more example. These ones are a bit tricky, and then we've got some old exam questions to have a look through. So same thing with this question. We want to factorize the top and the bottom. There are no common factors between 2x squared, 5x, and 3. So again, we're looking to factorize into two brackets. It's a terrible bracket. We know we need a 2x and an x because we have a 2x squared. We know that we have to use a 3 and a 1 because we've got -3, so we need to play around in order to get our -5x. Okay, so if we put our 3 here and our 1 here like we did last time, we know that we're going to get -x, so that's not going to work. Let's put our 1 here and our 3 here. 2x times 3 would give us 6x, and then 1x here we can use to get to 5. So because we want a -5x, we need to have -6x plus x to get -5, and 1 times -3 gives us -3. The denominator of our fraction, so we've got 2x squared plus 11x plus 5. No common factors, so we're going to go straight into two brackets. Again, 2x squared tells us that we've got a 2x and an x. We want 5, so we have to have a 5 and a 1. This time it's a +5, so we know that both of these numbers have to be positive because we also have +11x here. So we're going to double one number and add the other. So doubling 5 would give us 10, and adding 1 gives us 11, which means 5 has to go here and 1 has to go here. So that's factorized. If you're not sure if you factorized it correctly, expand and just double check. So I guess a little bit of comfort knowing that you can do that. Once we've got this far, we've got 2x plus 1 as a common factor, so they cancel, and we are left with x minus 3 over x plus 5. Okay, no more common factors. Temptation exists for some people to cancel out these x's because you've got an x at the top and the bottom. These x's are not factors. They're not multiplying anything. So they're not factors. That means that you can't cancel them. So we need to leave it with x minus 3 and x plus 5. Okay, we found our factors when we factorized. X's are not factors in this stage because they're not multiplying. Okay, so I've got two questions from the 2019 paper that we're going to go through. So the first one is just asking us to simplify that fraction. It doesn't tell you how to do it, it just asks you to simplify. So we know that we need to find common factors. To do that, let's factorize. So taking the top line, our highest common factor is 3x. So we have a 3x and x plus 3. And then the bottom line, x squared minus 9, we can factorize it. It's a quadratic. Doesn't have any common factors, but we can factorize into two brackets. It's one of those difference of two squares again. And we saw one of those in an earlier question. This time we want two numbers that multiply to give us negative 9 and add to give 0. So the only way we can do that is if we have x minus 3 and x plus 3. Okay, and then our x plus 3 is a common factor. So they can cancel and we are left with 3x over x minus 3. We're done. So for this question, if you get all the way through and you get 3x over x minus 3, that's merit level skill. If you didn't quite get that far, to get achieved or to show an achieved level skill, you can correctly factorize either the numerator or the denominator. So you don't have to correctly factorize both. One or the other will be sufficient for achieved. Or if something weird happens and for some reason you don't correctly factorize either of them, but you can still show that you can simplify by cancelling out common factors, then you can still get achieved for that skill. You just have to make sure that you haven't made it too easy to simplify, that's all. So you still have to have common factors in brackets. Okay, so just to reiterate, all the way through is a merit level skill. Factorizing either the top or the bottom of the fraction correctly will give you achieved, or if something goes wrong and you factorize these both incorrectly but can then consistently simplify your particular fraction, you might still be able to get achieved for that. Okay. Second question here, we are adding fractions and all I ask you to do is write it as a single fraction. Okay, so we know in order to do that we need to find a common denominator. Our lowest common denominator with 4 and 3 would be 12. So we want to multiply all of this by 3. So we have 3 times 8x minus 1 and that common denominator of 12 at the bottom. This needs to be multiplied by 4 and we are adding, so plus 4 times 3x minus 5. And again, we know that we've got our common denominator of 12. From here we expand. So 3 times 8 is 24x minus 3 plus 12x minus 20 all over 12. And then we simplify. 24x plus 12x is going to be 36x minus 3 minus 20 is negative 23 all over 12. Checking to make sure we've got no common factors. 23 is not divisible by 2, so that's not going to work. In fact, 23 is a prime number, so there are no common factors. That's as simplified as it gets. So this question, again, if you get all the way through, you get your 36x minus 23 over 12. That's a merit. If you get the correct arrangement of your numerator, then that's achieved level skill. So even if something goes wrong when you're simplifying down here, if you can get that right arrangement for your numerator, then that's your achieved level skill. If you've done something weird here, but you consistently expand it out and simplify, then that's achieved as well. Okay, so that might be useful for you to know. All right, and I've just got 2 more questions. So these are from the 2018 paper, and they'll look somewhat similar to the last 2 questions that we did. Okay, so in the last 2 years at least, we've had questions where we are adding and subtracting algebraic fractions and also where we're simplifying with that factorizing skill. Okay, so again, let's look for common factors. So at the top line, we've got a common factor of 3x. So 3x can come out in front, and then we have x plus 4. And then x squared minus 16. Hopefully these are becoming a little bit more familiar now. That's that difference of 2 squares. So multiply to give negative 16, add to give 0, x minus 4, and x plus 4. Cancelling out our common factor, we're left with 3x over x minus 4. Okay, and the marking is the same as the 2019 paper. So all the way through gives you merit. correctly factorising either the numerator or the denominator gives you achieved, or if something goes wrong but you can consistently simplify the fraction that you have in this step, then that may give you achieved as well, just depending on how difficult that simplification was. Last question. Adding two fractions. We did an example like this earlier. We're writing as a single fraction. We need a common denominator. Because we've got x plus 1 and x minus 2, we need to multiply those two things together in order to get our common denominator. So that means that our 2 up here is going to be multiplied by x minus 2. And at the bottom we have our x plus 1 and our x minus 2. Again, I'm going to leave it factorized. I'm not going to expand it. This one here, our 3 needs to be multiplied by x plus 1, and we are adding, so we add 3 times x plus 1, and we've got our common denominator down there already. Expanding and simplifying, we get 2x minus 4 plus 3x plus 3 all over x plus 1 and x minus 2. Simplifying our top line, 2x plus 3x is 5x, negative 4 plus 3 is negative 1 over x plus 1 and x minus 2. Okay, and that's all you need to do. You don't have to expand. I recommend, as I've said before, leaving it factorized so you can look for common factors, and it also means less work because you don't have to expand it out. And again, marking is the same as in 2019, so all the way through will give you merit. If you can get the right arrangement for your numerator, then that would be achieved. Or if something goes wrong here, but you can consistently sort of expand that out and simplify, then that will get you achieved as well. Okay, cool. So that brings us to the end of this lesson. I'm really sorry about the hiccups that we had earlier with the video getting out of sync and the freezing and whatnot. Hopefully next time will be better. So Wednesday is our next session, and we're looking at solving linear equations. Okay, so again, we'll be drawing on some of the skills that we've covered in previous lessons in order to solve equations. So I'll go through some examples, and then we'll look at a few old exam questions for that. Awesome. And then on Thursday, I'll come online at 5:30. If anyone has any questions, you can ask them there, or you can email them through to me and I'll answer them in that live session on Thursday. If no one has any questions, then I might only be on for 5 or 10 minutes. Yeah, but that's just an option, an opportunity for you guys to ask some questions if you need to. Cool. Hopefully that was good. You learned something today. Go and practice. I've used all of the questions from paper A, so it might be a good idea to go and get paper B from the NCEA website and have a go at these questions. You'll find them, they'll have different numbers, but it might be good to practice those. All right. Have a lovely evening.